Hey guys, welcome back. So in this video, we'll be covering ArrayList in Java. So this is not going to be a shortcut tutorial, rather I'm going to cover everything in detail about ArrayList. Okay, so let's get started. Okay, so before I talk about ArrayList, let's talk about array for a moment. Okay, so let's say I have a few elements here, right? Let's say I have few numbers here, 10, 11, 12, 13 and 14. Let's say there are 5 numbers here and I want to represent all this number, or I want to store all these numbers in Java. So how can I store all these numbers? Obviously I can take variables, right? A variable, B variable, C, D and E variables of int type, and I can store all these numbers here in these variables, right? But what about if I have 100 variables? If I have 100 number, if I have 100 number of numbers, then I cannot go ahead and I cannot declare 100 number of variables here, right? That's a bad approach. So rather what I can do over here, I can see one thing. This is of int type. All these numbers are of int type, right? So what I can do, rather creating variables here, I can create an array, right? So using array, I can represent all these elements, right? So what I can do over here, I can count all this number. Okay, 1, 2, 3, 4, 5. I want to store 5 number of numbers. So I can do int I array equal to new int of 5, right? So what will happen? There will be 5 number of indexes will be created here. 1, 2, 3, 4 and 5. So you know array indexes starts from 0, 1, 2, 3, 4, right? Then I need to insert all these elements to this array indexes. So how can I do it? I can do like I of 0, I want to insert 10, like I of 1, and I want to insert 11, I of 2, and here I want to I want to enter 12, and like this I can enter all these elements, right? So 10 comes here, 11 comes here, 12 comes here, 13 comes here, and 14 comes here. Simple, right? Simple array concept. Okay, so right now everything works fine for me. But let's say now I have a requirement. Okay, I want to insert another element called 15 here. Okay, so up to how many indexes right now we have? I of 3 we have, I of 4 we have, right? I of 3 is 13 and I of 4 is 14, right? Up to 14 we have entered the elements. Right now I want to insert this element 15. Okay, so can I do this? I of 5 equal to 15. Can I do this? The moment you are going to do this, you are going to get an exception. And can you guess what is the exception that you are going to get? You are going to get array index out of bound exception, right? Okay, so here we discovered a problem, right? So there is no indexes available here. So if there is no index available here, how can I insert this number here into this index? Okay, so if I'm even if I'm going to do it, I'm going to get an exception in the runtime called array index out of bound exception. Okay, so this is not possible. Okay, this line will give us an exception. Okay, so this is kind of an invalid piece of code. Okay, so why I want to say all these things to you. Okay, one thing I want to make you realize. Okay, whenever you are declaring an array, okay, the moment you are declaring an array here, the size of the array is fixed. This is fixed in size, right? This is fixed. And if you are going to insert any elements, whenever the bucket is full, or whenever all the indexes are full, at the time you are going to get an exception called array index out of bound exception, right? So arrays are fixed in size. Okay, so I think we're all good. Let's go for the collection right now and let's talk about ArrayList. Okay, and let's see how ArrayList is going to help us to solve this problem. All right, so let's go for it. Alright guys, so now let's talk about ArrayList here. Okay, so if you talk about ArrayList, okay, so ArrayList is a class, right? So it comes from, okay, let's talk about your root interface. So there is an interface called collection, in your java.util package, right? Java.util package, there is a interface called collections, right? And inside the interface, we define some common methods, right? So it holds some methods here, right? And there are some sub interface. One interface name is called list, and one interface name is called set, right? So list is the interface and set is the interface. So these are the sub interface of collection interface, right? So I mean, this interface extend this interface, right? Obviously, now just think, okay? In this collection interface, there are some methods, right? Again, those methods are coming to list, but all this method this interface has, they don't have anybody, right? So all this method cannot function. So to make it work, we should have some implementation classes, right? We have understand the interface concept already, that if you have an interface, we should have some classes to which will implement that interface, and whatever the method that we have inside our interface, those methods we need to override inside the implementation classes to make it work. Okay, so like that, for this interface there are some implementation classes. One class name is ArrayList, another class name is linked list, and another class name is vector. Okay, and stack is there. I'll not talk about it right now. Okay, so ArrayList is a class, linked list is a class, and vector is a class. Okay, so this is the complete hierarchy. So we'll not be talking about set right now. I'm going to pick list here, and I'm going to pick this particular class, and let's explore this class, right? Why this class is getting used, when it is going to get used, and why we need this class. Okay, we'll talk about the functionality of ArrayList class. All right. Okay, so guys, before I talk about the functionality of this particular class, let's explore this particular interface a little bit more. Okay, so right now, okay, so this particular this particular list interface does have some special kind of does some special kind of work. Okay, and obviously there are some implementation classes, and all these classes role is different. They have some different role. Okay, but before understanding their role, let's understand their parent role. Okay, what this particular list defines. Okay, so to make you understand this, forget about Java right now. Okay, let's use our common sense and let's understand few more thing over here. Okay, let's say I have few elements 10, 11, 10, okay, let's say 10, 11, 12, 13, and 30. Okay, there are 6 elements here. Okay, and let's say I have a bucket. So let's say this is a bucket. Okay, forget about Java. Okay, I told you forget about Java, right? So this is a bucket, and this bucket name is list. Okay, so if I want to insert all these elements to this bucket, what is going to happen? Okay, let's talk about that. So if this is a list, because the bucket name is list, if I'm inserting this 10 number here, this is going to be entered. Fine. And then if I want to insert 11, this is going to be entered over here as well. Then I want to insert, because 11 over comes here, then I want to insert 12, right? 12 comes here. Then I want to insert 13, so 13 comes here. Then again I want to enter 13. Wait, so this is a duplicate, right? So 13 number is already here inside this bucket called list. So can I insert again 13 here into this particular list bucket? Obviously I can do it. Okay, if it is list, then I can insert duplicate element. Okay, so right now 13 is a duplicate, but 13 is present here, but it's not a problem because this bucket is list, and remember inside list we can enter duplicate elements. So 13 again comes here. Again I want to enter 13. Wait, 2 times 13 is here. Now 13 is going to come here. Obviously yes. Why? Because this is a list, and inside the list duplicate is allowed. All right. Okay, so one thing that we understand right now, this list can accept duplicates, right? Inside the list we can we can enter duplicates element, right? And one more thing I want to say you, that if I want to display all these numbers right now, okay, the order we are inserting, okay, in the same order we are going to display, we can display all these numbers, right? So let's say my order of insertion is like this: 10, 11, 12, 13, 13. So in the same order, if I want to say, hey, hey list, display me all the elements that you have. So display, so list will say, okay, so the order you have inserted, in the same order I'm going to display you, right? So you have inserted 10 first, so I'm going to show you 10, and then 11, then 13, then 13, and then 13, because these are the elements that you have entered over here. Sorry, I missed 12, right? Okay, there you go. I think is clear. All right. Okay, so duplicates are accepted here, and we call this insertion order. Okay, and the insertion order is preserved. The way you are going to insert the elements, in the same way you are going to display it. I mean, the list is going to display it to you, right? So we can say insertion order is preserved. Okay, insertion order preserved. Okay, so right now we got to know two functionality of this list interface. First one is it accepts duplicates, and the second one is the insertion order is preserved, right? Okay, so now let's treat this bucket or this circle as a Java object. All right, now this is a Java object or a list object. Okay, now let's treat it like that. And what object means? Okay, we can create an object means, I mean, we create object for classes, right? So what class object this is? Okay, now let's pick this class object, ArrayList class object. Don't be confused. Let me wipe all these things. Okay, let it be here, and can I write here? All right, so let me clean up some space here. Okay, let me remove these stops. Let me remove this. I should purchase a new duster. This is not working. Okay, so as I said, ArrayList is a class, right? So let's create an ArrayList object right now. Okay, how to create an object? Okay, I don't think I should tell you that. You should tell me that, right? So I can write ArrayList list is equal to new ArrayList, right? And I should use the constructor here. Okay, so this is the default constructor. Okay, so this is my reference variable, this is my class name, this is the new keyword, and this is my ArrayList constructors. That's how that's how we create an object, right? So right now, the moment I hit this line, okay, so what will happen internally? An array will be created. This will happen internally, right? An array will be created. Whenever we do this kind of operation, internally an array will be created. But we understand, right? Whenever we are creating an array, we need to define the size. Okay, without defining the size, can you create an array? No, right? So internally, if it is creating an array, there must be some size, right? What is the size of this array? Who is defining it? We are not defining it anything over here. So what is going to be the size of this array? You have to remember, whenever you are using this constructor, this is a default constructor, and whenever we are using default constructor, the size of this array will be 10. Okay, this is called capacity. Okay, this is called capacity. So the capacity of this array will be 10. That means there will be 10 number of indexes will be created. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to create one more. Oh, sorry, 0 to 9 is 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 number of indexes will be created here. So here is the first point you have to remember. Whenever we're creating an ArrayList object by using the default constructor, you are going to create an array. An array will be created internally, and that size of the array will be 10, the number 1 point. Okay, so right now let's insert few elements into our array, right? So how to add few elements over here, how to insert few elements of few numbers here inside this array. We can do this. List is my reference, and list is my ArrayList class reference, right? Inside this ArrayList class, we have a method called add method, right? So we can use this add method, and we can pass whatever the number that we want to insert here. Okay, so let's say list.add. I want to insert the number 10. So 10 comes here. Now I want to insert another number. Let's say 11. So 11 comes here. I want to insert an 11 number. List.add of 12. Now 12 comes here. Like that, I can insert all the numbers. Let's say 13, 14, 15, 16, 17, 18 and 19. So I have inserted 10 to 19 with this particular array list, right? Okay. So right now, let me do it. Let me do list dot add of 19. So now 19 comes here. Okay, simple. That's how we are going to add our elements into our array list, right? And this array list is internally using an array, and in this array, whenever we're inserting all this, all these numbers, it is just coming here to this array, right? Simple. Okay, so now let's talk about something else. All right, guys. So now I want to drag your attention to here because I'm going to ask you a few questions, right? Okay, so right now this is our array. This is all the numbers that we have inserted to our array, and this array is there in this array is the internal implementation of this array list. Whenever we create an array list object, and an array will be created internally, and whenever you are using the add method to insert any of the numbers into this array, this is how it is getting stored, just like a normal array, right? But right now I want to do what? I want to insert another element. Let's say list dot add of let's say 20. So now what is going to happen? All the indexes are full right now, right? So am I going to get an array index out of bound exception? Because see, everything is full, right? In case of array, we're going to get an exception called array index out of bound exception. But right now I'm doing the same thing. The buckets are full, the indexes are full. I'm adding an extra line here to the 10th index, but there is no 10th index over here. The size of the array is 10, 0 to 9 is 10. There is no 10th index over here, but I'm inserting this element 20 to here. So what is going to happen? Am I going to get an exception? Be sure, no. This array has some superpower, right? This has some superpower. This is not a normal array, right? This is a dynamic array. Okay, this is what kind of array? This is a dynamic array, or you can say it, this is a growable array. Okay, this is a growable array, or you can say it, this is a resizable array. You can guess it from the name, resizable array, right? So what is going to happen right now? So the moment I am going to insert an element over here, this array feels, dude, I don't have any space here to accept your elements. So what I'm going to do, internally again a new array will be created, and this array will be bigger than this array. But now you must be thinking, okay, that what is the size of this array? Okay, the array is created, that's fine, but previously the size was 10, right? Right now what is going to be the size of this array? Make sure the size of the array is something that you are thinking about, right? So the way this array is going to be defined by using a formula. Okay, and what is that formula? So the formula is current capacity into 3 by 2 plus 1. Okay, so right now what is the current capacity of the previous array? What is the capacity? The size of the array, right? The capacity is 10. So current capacity is 10 into 3 by 2 plus 1. So 2 10 comes 5, 5 3 is 15, 15 plus 1 is 16. So the next array size will be 16. So that's how this is getting defined. Okay, so this is a resizable array or a growable array or a dynamic array. Dynamic means it's always going to change, right? So right now it feels that, okay, there is no more indexes over here to accept the user value, so it is going to create a new array with this size. What is the size? 16. Now this is going to be the size 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, 0 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14 and 15. All right, so now you can see it, right? 0 to 15 is 16, right? So the size of the array is 16. You can see over here. Okay, so a new array is getting created, And once this array got created, what will happen, all the elements that over here in the previous array, this is going to copy to the new array. So now all the indexes will be get copied, right? So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, up to 19 we have, right? 0 to 9 now is got copied, right? Now there is some more, some what do we call that? Some more spaces. Oh, I'm so bad in English. We have some more spaces available here. Okay, so right now this is 20 we are to insert, right? Now 20 comes here and it's got happily inserted over here. You see it, how these things works? So the internal data structure, this is called the data structure. Internally, the Sun Microsystem people have implemented this concept, and this concept is called as dynamic array or growable array or resizable array. And this is the internal data structure, and this data structure has been internally implemented. So whenever there is some more space required, it is going to create a new array, and once this array is getting created, all the previous elements are going to be get copied to the new array, and the element that you want to insert, that is going to be inserted to the specific bucket. Simple, right? The corresponding bucket, this 20 is getting inserted. This is changing, this is happening automatically, right? So this is happening dynamically, so that's why we call it dynamic array. So this is another most important concept about ArrayList. So that's how things works internally, and I'm going to show everything how it is happening internally code wise in the upcoming tutorial. Don't worry about it. Sure, so we're all good. So right now let's talk about something else. Alright, so now let's talk about another point. Okay, so let me clean up some spaces here. There you go. Okay, alright, so right now we are taking this reference called list, which is my ArrayList reference, and we are adding all the elements to my array, right? So now let's say if I'll do system.out.println of list, what is going to happen? You need to guess it and you need to tell me. Okay, so I'm going to print this reference list here. So what is going to happen? So if I'm printing the reference of the list, this list reference here, which is my ArrayList reference. So this list, remember I told you, this is an object, this is a bucket, this is the Java object, okay, and this is the list object or the ArrayList object, okay, and I have inserted 10, 11, 12 up to 20 here. So whenever this ArrayList, whenever this list is going to display you all these elements, it is going to maintain the order, right? So here I'm going to print system.out.println of list. So what will happen? All the elements that we have inserted to our array, the way we have inserted, in the same way it is going to print. Let's say 10 we have inserted first, so 10 will come first. Definitely it's going to come first. You have to trust list. That's going to be your best friend whenever it comes to insertion order, because in the list insertion order is preserved. Okay, so 10 we have inserted first, so 10 will come first. Okay, then 11, then 12, then 13 up to 20 will come in the same order. The way you have inserted, the same way it is going to display. So what we call it, insertion order is preserved. Okay, all right, so few things that we have learned as of now. Let's do a quick recap, because collection is something you have to always remember a lot of things over here. Okay, so list is the child interface of collection, and with the list there is an implementation class called ArrayList, and this ArrayList comes came in 1.2 version in Java. With the ArrayList, it accepts duplicates. We're going to prove it a little bit later, and the insertion order is preserved. Okay, so that's what we have learned over here. Whenever we're displaying something, the insertion order is going to be preserved. And the next thing that we have learned, whenever we create the ArrayList with default constructor, an array will be created internally with the size 10, and whenever we're inserting some elements, when the array is full, the internal array is full, a new array will be created with this particular formula, current capacity into 3 by 2 plus 1, and accordingly a new array will be created. And what if I'm going to, whenever this array will be full, again this particular formula will be get used. What is the current capacity? 16 into 3 by 2 plus 1, 8, 8, 3, 24 plus 1 equal to 25. So the new array size will be 25. Okay. So the next thing that we have learned is the internal data structure that they are using. The name of the data structure is dynamic array or growable array or resizable array, right? So whenever it comes to Java, you don't need to be worried about how the things working internally, right? Already the people have implemented, the developers at Sun Microsystem people, they have already implemented all these things internally. So you just have the class, you are going to just do this add method to insert the elements, and this is how it is happening internally, and you don't need to be worried about it. Okay, so this is the internal data structure. Okay, so there we go. So next thing that I'm going to talk about, yes, this point, duplicates are allowed. Okay, so let me wipe out some spaces over here. So let me wipe out all these things, and let me ask you a question. Okay, again, and another question. I know you're going to hate me. So okay, so now let's say this is a list and I have inserted 3 elements, 10, 11 and 12. Okay, so a array has been created. This is the default constructor with the size 10, right? 0, 1, 2 up to 10. Okay, we can set dot dot dot. Okay, so an array has been created. First I'm entering 10. Okay, so let me do the diagram for your better understanding. I shouldn't use shortcut here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 0 to 9 is 10. Okay, default capacity. Sure. Okay, so right now I'm inserting 10. The 10 comes here. I'm inserting 11. 11 comes here. I'm inserting 12. 12 comes here. Now again I want to insert list dot add of 13. Now what will happen? Obviously 13 comes here. Now I want to add list dot add of 13 again. Now what is going to happen? 13 is already present here. Now again you are inserting 13 here. So 13 will again come here, right? Why? Because this is a list. This is a ArrayList. Okay, ArrayList object. And this ArrayList has a special feature. If you want to insert, if your requirement is in your project, if you want to store the duplicate elements, then you should go for ArrayList. Okay, I mean you can go for any of the list implemented classes like ArrayList, linked list or vector, but here we are talking about ArrayList. So ArrayList is going to accept the duplicates. Again I want to insert list.add of 13 again. Now what will happen? Again 13 will come here because duplicates are allowed inside the ArrayList, right? And what about the rest buckets? Right now let's say 6, 7, 8, 9 buckets we are not using, so this will be null obviously. All right guys, so as of now insertion order will be preserved, duplicates are allowed, the internal data structure is resizable array or growable array, the default capacity will be 10. Whenever you are using, whenever you are creating your ArrayList by using the default constructor, the capacity will be 10. This much point we have learned, right? And the insertion order will be preserved when duplicates are allowed. I have already written it. Okay, no problem. The next thing, if I am doing here, okay, if I am doing list.add of null, what is going to happen? This null is going to insert over here or not? Obviously, right? If it is the ArrayList, then the null insertion is possible. So the null can be inserted to our ArrayList, right? Be sure about it, and we are going to practically prove it whenever we are going to do the practical session, right? So the null insertion is possible to a ArrayList. Another point. Okay, now the most important point, let's talk about it right now. So let me wipe out all these things. Alright guys, so right now let's talk about another most important feature of ArrayList, right? So let's say, okay, so right now I have written this ArrayList list equal to new ArrayList. That means I have created a ArrayList object, and inside, let's say this is the ArrayList object. Okay, and there is an array. Now, whenever we do this, an array will be created of size 10. So I've written 0 to 9, which of size 10, right? So right now let's insert few elements. So to insert, I need to use add. Let's say list.add of 1. What will happen? 1 will be inserted. This 1 is of what type? This is of int type, right? Now I want to insert list dot add of, let's say Avilash. Avilash is my name. Okay, so list dot add of Avilash. Now Avilash will come here. You see what is happening? Can you guess what the point that I want to prove? So list dot add. Let's say I want to insert a double value. Let's say 10.22. So what will happen? 10.22 will come here, right? If I want to insert list dot add of let's say false, a boolean value, what will happen? False will come here, right? So what is happening here? These elements are heterogeneous element, right? Int, string, double, boolean, right? So in our list I can insert heterogeneous elements, right? So one is of int type, Avilash is of string type, this is of double type, this is a boolean type. So whenever you talk about your list, or specifically ArrayList, then using ArrayList you can insert heterogeneous elements to the list. So there are a few points you need to remember. The first thing, the insertion order is preserved. The way you are inserting, the same order you are going to display it. Second thing, duplicates are allowed. If I am going to insert again list.add of 1, it is going to enter. 1 is present here, no problem. Again a 1 can be entered. So duplicates are allowed. Null insertion is possible. If I am going to do list.add again, and if I want to add a null value here, then the null is going to be inserted to this particular index. So null insertion is possible. Internal data structure is dynamic array or growable array. Whenever this array is going to reach its size, then again whenever we want to insert few elements over here, a new array will be created. This is called dynamic array or growable array. And the different types of different types of value we can insert to our list, we can call it heterogeneous element. Heterogeneous element we can be inserted to this particular list. These are the few points that you have to remember. Right now let's talk about something else about ArrayList. All right, so let's go. All right guys, so as of now we have understood a lot about ArrayList, right? So we understood that what ArrayList does. Right now we are going to learn that when we are going to use ArrayList, right? We understand all the features of ArrayList. So right now we'll be talking about when we are going to use ArrayList, right? Okay, so now let's say if I have a ArrayList, okay, if this is my ArrayList object, okay, and let's say there are 10 elements here, 1 2 3 4 5 6 7 8 9 and 10. Okay, 0 1 2 3 4 5 6 7 8 9. Okay, so now let's say I have done some add operation. So this is my list. Okay, so I did list.add of 10, and similarly I have inserted 10 11 12 13 14 15 16 17 18 and 19 to the list. Okay, so now what I want to do, I want to insert an element. Okay, I want to insert an element in the first index. Okay, so right now this is my array list, right? This is the array representation of all these things. Okay, 10 11 12 13 14 up to 19 I have inserted. Now I want to do list dot add. Okay, I want to add an element into a specific position. So which position I want to add? 1. So I'll write 1 here and I'll do a comma, and in the 1th position I want to insert 30, the number 30 here. But wait, there is a problem. The list is already full, and inside this list in the 1th position there is an element over here, there is a number over here called 11, but I want to insert 30 here. So if in this code will do what? This will push this 30 to this particular position. So 30 comes here. But what about this 11? So we cannot store 2 elements in a index, right? So obviously this 11 is going to shift here. So 11 comes here. But wait, there is an element over here called 12. Now 12 is going to shift here. Okay, so 12 comes here. But wait, 13 is here. Now 13 is going to shift here. So once the 13 comes here, the 14 is going to shift here. Now the 15 is going to shift here. The 16 is going to shift here. The 17 is going to shift here. And the 18 is going to shift here. And the 19 will be going to shift here, because this is dynamic array, right? So another bucket will be added if it is 10, and the 19 will be going to shift here. So all these elements are getting shifted because we are inserting this 30 here. So these are getting shifted. So this is what we called a shift operation. Okay, this is a shift. This is called as a shift operation. So whenever we are inserting an element into an array list, the elements are getting shifted, okay, to the corresponding bucket or to the next bucket, right? So at that time, what will happen? It will take a lot of time. Okay, think about, you have a bigger list. You have a list with 1000 elements, and you are inserting something into the first bucket. I mean, in the first index. At that time, this thing is going to shift to the next bucket. The next one will be going to shift to the next indexes, and this one is going to shift here. This one is going to shift here. This one is going to shift here, and like that, it will continue up to the 1000 bucket. I mean, up to the 1000 indexes. So this is a time-consuming process. This shift operation is a time-consuming process. Okay, so whenever your frequent operation is insertion operation, or you want to insert element to the list, or if you have a project, and in your project there is some need to insert element to the list, at that time the array list will be a bad choice, because if you are going to insert elements to this list, all the elements in that particular index need to shift to the next index, and the next index element, it need to be transferred to the next index again, and that operation will continue, and that operation is called shift operation. And shift operation usually takes a lot of time because it need to transfer that element to the next index. It's a time consuming process, and that's why for insertion operation, this array list is a bad choice. If you're using array list for insertion operation, this is not at all a good approach, okay, because of the shift operation. Okay, so now let's talk about the deletion operation. The same thing here, okay, the same thing here. Let me remove this, okay, 13, 11, 12, okay. All right, so right now, let's say I don't want to do the add operation right now. I want to do the remove operation, okay. I want to remove this 11 here, okay. I want to remove this 11. So there is again a method called remove, okay. So we'll be talking about all this method whenever we're doing practical, okay. So right now I want to remove this 11 element, I mean the 11 number from this first index. So I'll do list dot remove, and I'll do 11. Oh, sorry. I'll do what? I'll put the index number. What index element I want to remove? So I'll put 1 over here. So right now this 1 will be, the index number 1 element will be removed. Now the 11 is got removed. Now this bucket is empty. Now 12 comes here. Now 12, if 12 will come here, this bucket will be empty. Now 13 comes here. Now 14 comes here. Now 15 comes here. Similarly, all these elements need to shift to the previous bucket, right? Again, there is a shift operation happening here. So for deletion also, the shift operation is happening, and so for deletion also, the array list is a bad choice. So for insertion operation and deletion operation, if this is your frequent requirement in your project, you shouldn't go for array list, okay. Then you might be thinking, okay, so when we are going to use it? You bore me for last 1 hour, and now you're saying me that don't use array list. So when I'm going to use it, okay. So let's talk about when we are going to use it. Okay, so now let's say, let me remove this. If your frequent operation is retrieval operation, if you want to retrieve, okay, for retrieve we have a method called get, okay. Just tell me, okay, if I'm going to print system.out.println of list. So let's say the list is my array list reference. So if I'm writing list here, it is going to display all the elements which is present inside the list. But let's say if I want to retrieve a specific element from a specific index, then what I can do? Let's say if I'm going to do this list dot, I want to get the what is present there inside the first index. So I'll do list dot get and I'll write 1. So this 1 is the index number. What is present inside this 1th index? 11. So 11 will be the output. Okay. If I'll do list dot get of 0. So what is there inside the 0th bucket? 10. So 10 will be the output. Okay. So similarly, so now before I go further, okay, so let's say if you're doing list.get, you are trying to retrieve the first index element. So this is giving you 11. Let's say this is taking 1 second to retrieve because this is the first index, right? Now you are doing list.get of 0. So you want to insert the first index, first element in the list. This is giving you 10 because 10 is present here. Let's say for this is the first element. This is also going to take 1 second. So see, for first index also it is taking 1 second. For 0th index also it is taking 1 second, right? If I'll do list dot get of let's say 7. Inside the 7th index we have 17. So the output will be 17. Make sure this is also going to take 1 second only. So irrespective of what index you are going to fetch, it is going to take the same duration of time. If you are going to retrieve the list.get of 1000, you want to retrieve the value which is present inside the 1000th number index. For that time also it is going to take the same amount of time, 1 second. Okay, if this is 1 second, this is going to be 1 second, this is going to be 1 second, this is going to be 1 second. The reason why for all the indexes it is taking the same time, because it implements the ArrayList class, implement an interface called random access interface. Okay, random access, this is the interface name, this is the interface. So your ArrayList class implements this interface called random access, and this random access helps us to retrieve the element in the same duration of time. So one more thing you have to remember, this random access is a marker interface, right? This is a marker interface, and you know inside your marker interface we shouldn't have any method. So this random access is providing this feature for retrieval operation. The time it will consume the same amount of time for each retrieval operation whenever you are using get operation, right? Because the random access is getting used, the random access is the ArrayList is implementing the random access interface, and the random access interface is making this possible to retrieve all the elements in the same amount of time. And what is a marker interface dodge? If you want to know that, I have a different tutorial available in my channel, you can watch that. Okay, so this is what the whole thing is. Okay, and one more thing, in your entire collection framework there are only 2 classes who implements this random access interface. One is ArrayList, another one is vector. So this ArrayList and vector, these both classes are used for retrieval operation because they have implemented this interface called random access interface, and that's why for retrieval operation it is going to take same amount of time irrespective of the indexes that you want to retrieve the value for. Okay, so here is the conclusion. Okay, for insertion and deletion the ArrayList is a bad choice, but for retrieval operation the ArrayList is a good choice. It is the best choice. Okay, because it implements random access interface, right? Simple. Few things we want to recap again before we wrap up. Okay, heterogeneous elements are possible, insertion order is preserved, duplicate elements are allowed, null insertion is possible, internal data structure is dynamic array or growable array. Whenever you create a ArrayList object by using the default constructor, the size of the array which will be created in the memory will be 10, and then it will use a formula current capacity into 3 by 2 plus 1 to determine what will be the next size of the array. Okay, and then the ArrayList is the best choice for retrieval operation because it implements the random access interface, but it is bad for insertion and deletion operation because of the shift operation which is taking place, right? So this is the entire concept of ArrayList. So right now most probably I'm going to do the practical of it. Alright guys, so that's it for today's video. Thank you very much for watching this video. If you like this video, don't forget to hit the like button, and just let me know if this kind of tutorials are beneficial for you, or if you are enjoying this kind of sessions, or any of the suggestion if you have, you can write down below, or you can mail me to my email ID seleniumexpress@gmail.com, or you can just message me in my Facebook page. I'll just give you a response back, and I'll be glad to hear a few response from you guys. Okay, so do comment, do like, and let me know if you like this tutorial or not. Okay, thank you very much guys for watching this. See you in the next video. Bye bye.